How does the shape of a wave change as the source of the wave changes? Wavelength. So the distance between one point on a wave to the same point on the next wave, we called it as wavelength. The distance between a certain point on a wave to the same point on the next wave, we called it as a wavelength. Longitudinal waves are measured from one compression to the next compression, or one rarefaction to the next rarefaction. Okay, so the distance for longitudinal waves, from one compression to the next compression, or one rarefaction to the next rarefaction, this is the wavelength. Okay, so the wavelength repeats as long as the energy remains constant. The wavelength will repeat as the energy. As you shake your hand with the same speed, so the wavelength will repeat itself, will be the same, equal. Each wavelength equal to the next wavelength, and so on. As long as the energy is constant, wavelength is measured in unit of distance. It's a distance, it's a length. So it has the same units of distance, such as meter, centimeter, and etc. Okay, so this is the wavelength for transverse. The distance from crest to crest or trough to trough is the same distance as long as the energy is constant. And here for longitudinal, the distance from compression to compression or rarefaction to the next rarefaction. So wavelength is the distance from crest to crest or trough to trough, or wavelength the distance from compression to the next compression or rarefaction to the next rarefaction. So this is the wavelength. Now let's read about frequency. Waves have another property called frequency. Frequency of a wave is the number of times the pattern repeats in a given time. So the number of times that the pattern repeats in a per time, this is the frequency. Frequency related to how rapidly the object or a material producing the wave vibrating. So how much the vibrating produced in the object. Each vibration on an object produces one wavelength. As we know that one vibration equal one wave, which is equal to one wavelength. The frequency of a wave is the same as the number of vibration the vibrating object makes each second. Okay, so the number of waves in 1 second, this is the frequency. This SI unit of frequency, hertz, Hz. A wave with a frequency, for example, 2 Hz, means that we have 2 wavelengths passes a point each 1 second. Okay, so if I told you that the frequency of a wave is 2 Hz, means 2 wavelengths will pass a point each 1 second. Okay, the unit Hertz is the same as the unit 1 over S, or S to the power of -1. So they are equal. Hertz, or 1 over S, 1 over second, because the number of waves per the time, which is equal to second to the power of -1. The amount of energy transferred by waves in a given time is proportional to the wave's frequency. The amount of energy transferred by waves in a given time proportional to the wave frequency. As the amount of energy, as you give the waves more energy, it will produce more waves, so means more frequency. If the frequency of the waves doubles, the energy of the wave also will double. Similarly, if the frequency decreases by the half, also the energy will decrease by the half. So if the frequency of the wave double the energy of the wave, so we have proportional relationship between what? Between frequency and energy. If you double the energy, the frequency will double. If you decrease the energy to the half, the frequency also will be decreased to the half. So now let's read about the relationship between wavelength and frequency. So now we already know the definition of wavelength is the distance from rarefaction to rarefaction, or compression to the compression in longitudinal waves, or from crest to crest, or trough to trough in the transverse wave. Also we read about the definition of frequency, which is the number of waves in 1 second, or the number of repeating patterns in each time. So now we are going, and we also told about the relationship between the frequency and the energy, and we said that that frequency is proportionalship with the energy. Now we are going to talk about the relationship between wavelength and frequency. The properties of waves are not independent of each other. So the strong relationship between the wavelength, we have a strong relationship between wavelength and frequency, as the figure below shows how frequency and wavelength are related. The wavelength of the wave on the top section is longer than on the bottom one. So look for this one, for example. As you see, we have this is a transverse wave. Also, we have here a transverse wave. As you see here, we have more wavelength, because we have here more distance from this trough to this trough, sorry. So the distance from this trough to this trough is more from the distance from this trough to this trough. So this this wave, the first one, it has more wavelength than this one. Okay, so let's see if we this is in second 0. So what about after 1 second? As you see here, after 1 second, how many waves we have here? This is the first wave, 1, 2, but here we have only 1 wave. So as we know that the number of waves per the second, per the time, this is the frequency. So here after 1 second we have 1 wave, so 1 wave over 1 second, so the frequency is 1 hertz. Here we have 2 waves per 1 second, so the frequency here is 2 hertz. So as you see here 1 hertz and here 2 hertz, so the second wave has more frequency than the first one, but the first one has more wavelength than the second one. Also here after 2 seconds, as you see here, the number of waves also increase. So here, as you see, we have more frequency than the first one. As you see, after 3 seconds and after 4 seconds, in each time, the number in each time, the second wave has more frequency than the first one, because it produced more waves than the first one. So here, the first wave, more wavelength, less frequency. The second one, less wavelength and more frequency. So what do you think about the relationship between a wavelength and a frequency? As you see, it's inverse relationship. So to calculate the frequency of a wave, so again, the relationship between the frequency and wavelength, they are inverse relationship. If one decrease, that increase. If we have more wavelength, so we will have less frequency, and if we have less wavelength, we will have more frequency. Now let's see how we can calculate the frequency of waves. To calculate the frequency of a wave, divide the number of wavelength by the time. So for the wave on the top, the frequency is 1 divided by 4 seconds, so it's 0.25 hertz. The bottom, the frequency is 0.5 hertz, so the wave on the bottom has a shorter wavelength and a higher frequency. So as the frequency of a wave increase, the wavelength also will decrease.